Fasten your seatbelts, space travelers. Imagine this January 1st, 2023, Earth's worst nightmare becomes a reality as a gargantuan meteorite, bigger than Pluto, is hurtling straight for our home planet at lightning speed. But just before the cosmic doomsday clock starts ticking, tiny probes sent from the edge of Saturn's orbit intercept this asteroid-sized menace. With their cutting-edge tech, they scan the monster and make an astonishing discovery. It's completely mineral-free. The mission team back on Earth breathes a sigh of relief as the probes return empty-handed. But little do we know, our secret defense forces in Alaska have been secretly gearing up for battle. A top-secret laser system is being set up to save humanity from this extraterrestrial threat. Buckle up, space enthusiasts. In an instant, our cosmic drama takes an explosive turn. A blinding solar flare reduces the giant meteorite to nothingness. It's as if Earth's guardian angel just saved us from an extinction-level event. Fast forward to the future, when humanity reaches Type 2 civilization status on the Kyrgyzov scale. We'll have unlocked almost limitless energy sources and possess the power to either fuel our journey into the stars or defend against any intergalactic threats with a mere snap of our fingers. But here's the million-dollar question. Would this advanced era really bring us true safety? What if, instead of an asteroid, it's something even more formidable that could wipe us out? A rogue artificial intelligence, a nearby supernova, or perhaps a rival civilization with their own game-changing technology. The possibilities are endless and raise a crucial question. What does the future hold for this newly empowered humanity? Get ready to expand your cosmic horizons. To become that powerful Type 2 civilization on the Kyrgyzov scale, we need to tap into more than just our planet's resources. We're talking about harnessing energy straight from the sun itself. And we're not just talking about those regular solar panels you see today, we're thinking massive. Welcome to the concept of a Dyson sphere, a mind-boggling megastructure first, proposed by Professor Freeman Dyson way back in 1960 at Princeton University. Essentially, this colossal shell would encompass an entire star and its closest planets, collecting all that stellar energy and converting it into electricity, with some heat radiated away as infrared light. Just imagine the limitless power at our fingertips. Now let's dive into just how big and ambitious this Dyson sphere really is. Picture it, its radius stretches out exactly 1 astronomical unit. That's from our Earth all the way to the sun, and the material making up this megastructure, a mere 3 meters thick. But you might wonder, what could possibly go wrong with something so gigantic? Well, nearly everything. First up, and perhaps most obviously, is the staggering amount of resources we'd need to build it. Materials, labor, and technology on a scale that's almost unimaginable. To put our resource requirements into perspective, we're talking about an unfathomable 1.5 to 10 to the 24th power tons of material. That's equivalent to Jupiter, the largest planet in our solar system. To construct such a massive Dyson sphere, humanity would have to mobilize an industrial-scale operation, exploiting every asteroid within reach and even deconstructing several rocky planets for their constituent materials. But it doesn't end there. Our engineering are just beginning. This megastructure has to be near perfectly spherical in shape, meaning any deviation from a flawless sphere could lead to catastrophic structural issues, putting the entire project at risk of collapse. Here's the catch. Our spherical superstructure has to withstand the crushing force of the sun's gravity, or risk getting squished into a foil ball. The materials we'd need to construct it are stronger than any current tech, even surpassing the might of advanced carbide, which outclasses graphene. But if we somehow manage to defy engineering odds and build this megastructure, we're not off the hook yet. Our Dyson sphere would remain extremely unstable. Think about it. For this colossal shell to function, the star at its center must sit perfectly still, like a delicate, celestial marble in a cosmic bowl. But what if an asteroid came crashing in and nudged our Dyson sphere off-center? The result would be catastrophic. It'd start drifting towards the sun and eventually crumple under its intense gravity. So, does this mean we're stuck on the drawing board forever? Not quite. It turns out, humanity got a bit mixed up about Freeman Dyson's vision for his eponymous megastructure. Instead of a solid, impenetrable shell, it was actually a swarm of tiny satellites dancing around a star in perfect harmony. Now imagine a Dyson swarm. Not one massive, monolithic shell, but countless tiny satellites working together in harmony, harnessing the sun's energy and beaming it back to Earth or another receiver via wireless waves. This concept is already looking more feasible than ever. Sure, we'll need some serious technological advancements to make wireless transmission a reality, but trust us, the payoff will be worth it with less material needed and greater stability at play. This swarm of satellites could just become our ticket to unlocking limitless solar power for generations to come. Hold up, you think the Dyson name is exclusive to spheres or swarms? Think again. There's actually more to this stellar concept than meets the eye. Enter the Dyson bubble, a mesmerizing system of satellites with solar sails that appear to defy gravity, floating eerily around their star. And that's not all. We also have the Dyson shell, which flips our perspective on its head by offering a habitable interior space. But let's not stop there. Folks, other alternatives like the Pokrovsky shell and Nevin ring are also vying for attention. The point is, no matter which megastructure humanity ultimately chooses to build, we'll face unique challenges that will push us to think outside the box, or sphere, bubble, or ring. Here's the thing. To get our megastructure game on track, we're looking at needing a whole lot more resources than what our home planet offers. That means it's time to go asteroid mining. But hold up, while disassembling some asteroids won't be a big deal, messing with planets is an entirely different story. Imagine if we started breaking down Venus or Mars for materials. Not only could we throw off the balance of our solar system, but we'd also risk changing Earth's orbit. And let's not forget about the other major issue: a full-blown Dyson sphere would block sunlight from reaching beyond Earth's orbit. Game over for any Mars colonization dreams and Pluto exploration plans. But here's the thing, we're not just talking about a few technical hiccups. When it comes to building a megastructure around our sun, we're looking at major risks like solar flares that could knock out any structure in an instant. But even that's not the biggest hurdle. Think about this: our star pumps out an insane 4 times 10 to the 26th power joules of energy every single second. We're talking mind-boggling levels of power here. Now, let's assume our megastructure can only snag about 10% of that. Even then, it would still collect a whopping 40 trillion times more energy than what humanity uses in an entire day. That's a lot to handle, and it raises some seriously big questions. How do we even begin to transmit and store all that power? The answer might just lie in converting sunlight into antimatter. But that's a whole different can of cosmic worms. Now we're getting into the real cosmic conundrum. Storing all that energy isn't just a technical challenge, but also a major safety risk. Because, let's face it, we've got no clue how to safely stash away antimatter on a massive scale. But don't worry, our genius minds have come up with some wild ideas for containment. Imagine building magnetic field traps strong enough to keep antimatter from annihilating everything in its path. Talk about a high-stakes game of cosmic ping-pong. Another approach is chilling out the antimatter to super cold temperatures. But even then, we're looking at iffy storage solutions that might not hold up when dealing with huge quantities of unstable antimatter. But here's the thing, if we mess up, we're not just talking nuclear-level catastrophic. Antimatter reactions could blow everything to smithereens. When matter meets its opposing force, it's not a peaceful merge. Instead, they annihilate each other, unleashing an insane amount of energy. Now, picture building that Dyson sphere. Every step from concept to construction is a minefield of potential disasters waiting to happen. But let's dream big. As we reach Type 7 civilization status and physics becomes our best friend, we might just pull off the impossible: a limitless power source. But here's the burning question: will all our problems magically disappear once we've got energy flowing like water? The limitless energy possibilities are tantalizing, but what's the ultimate goal for this powerhouse-type civilization? Maybe they'll bring every planet, satellite, and space rock in our solar system to life. Imagine tapping into the Kuiper Belt's mineral wealth, siphoning hydrogen from Jupiter, or cultivating avocados on Phobos. It sounds like a space-age utopia, and with advanced hydroponics tech, Mars and its moons could transform into massive automated farms where crops grow in abundance under controlled conditions. The vision is breathtaking. Our solar system becomes one giant, thriving ecosystem, all thanks to that infinite energy source. Get ready for a material revolution. Graphene and aerogel are going to change everything. They're about to replace plastic for good. With these superpower materials, we can create next-gen spacesuits that shield us from radiation, extreme temperatures, and solar wind like never before. But that's not all. Their impact will extend far beyond space travel. Imagine a world where fractures and bone problems become a thing of the past, thanks to strengthened skeletons. And if that weren't enough, we'll also be harnessing genetic modification like never before. The possibilities for human enhancement are endless. Stay tuned as we dive deeper into this fascinating future. Imagine a world where beauty salons aren't just for haircuts and makeup anymore. They could be upgrading your DNA. But the real game changer: no more bulky gadgets like computers and smartphones. Instead, a tiny chip will give you superpowers in the form of brain-to-computer interfaces. Want to send a text or post on social media? Just think it. Need access to every piece of info ever created. Instantly get it with just your mind. These innovations aren't just about convenience. They'll revolutionize how we learn, process thoughts, and connect as humans. Buckle up for the future where our minds become the ultimate interface. Conspiracy theorists, listen up. Even you'll have options without going under the knife. Just think futuristic shades like upgraded Google Glass. But here's the bigger picture: as we enter this new era, space won't be our biggest worry anymore. Instead of asteroids being a threat, they become an untapped resource waiting to be harnessed from the Oort cloud or even beyond. And if something does pose a danger, get ready for humanity's secret ace up its sleeve: a lightning-fast defense that can take out any incoming menace in seconds. The universe just got a whole lot more manageable. Hold on to your space helmets. Scientists might just give in to their inner Star Wars fans and build something straight out of sci-fi. Imagine a spherical super satellite orbiting Earth, about 160 kilometers across, packed with antimatter power. When our cosmic early warning system picks up an asteroid heading straight for us, the Death Star will unleash its mighty beam of antimatter, giving that space rock the ultimate force push. Here's the cool part: to blast it into oblivion, we only need a nudge stronger than what gravity is holding together, and voila, problem solved. But here's the catch: we're not talking about just blasting asteroids. We're talking game-changing force levels. To make this antimatter beam work, scientists would need to pack an enormous punch. The antimatter fired must be a whopping 200 million times more massive than the asteroid itself. Let me put that into perspective. Apophis, the space rock that's had some pretty close calls with Earth, tips the scales at 27 billion kilograms. With this Death Star tech, though, we'd only need about 5.5 kilograms of antimatter to send it packing. Now, if we had such a device, would it bring world governments closer together or create an even bigger divide? One thing's for sure: with a Type 2 civilization on the horizon, humanity might be in store for a future that's both wildly different and potentially game-changing. You've got to wonder, what happens when someone with a destructive streak gets their hands on this kind of power? They could potentially level entire planets. But, surprisingly, experts think humanity's greatest threat won't come from within, but from beyond our cosmic neighborhood. A Type 2 civilization would likely have the upper hand in defending against any external threats. They'd be able to vaporize any object hurtling towards us, neutralizing asteroid impacts and other interlopers before they even become a problem. So buckle up, space fans. It looks like our future might just get a whole lot safer. Get ready for the ultimate plot twist. Just when you thought our advanced technology would save us from any alien threat, experts reveal a chilling truth. It's not asteroids or rogue asteroids that we should fear, but actual extraterrestrial visitors. If an alien civilization makes contact with Earth, it'll likely be a Type 3 on the Kardashev scale, meaning they're harnessing energy from stars and galaxies far beyond our own. With power like that, our best defense would be like a toy gun against a laser cannon. So, the first step for our Type 2 civilization: trying to stay under the radar and avoid drawing attention to itself. Easier said than done. Now let's talk about the cosmic cloak of invisibility, or should I say, the Dyson sphere's glow. Any megastructure a Type 2 civilization builds around their star will give off heat signatures in the form of infrared radiation, making it super visible to other spacefaring nations. Or should we say, civilizations. And get this, our own scientists are actually on the hunt for these heat trails in the universe. In 2015, a researcher at Penn University took a stab at finding signs of advanced life by scanning over 100,000 galaxies in infrared wavelengths, and guess what? No alien megastructures were found. So does this mean we're completely alone in the universe? Not likely. it's possible that intelligent life is out there, but maybe they're just masters of stealth and don't want to be found by intergalactic researchers. But hold on, it looks like our luck changed when a duo of scientists from Manchester and Beijing got their hands on data from 16,000 galaxies in 2021. They discovered that 4 of these galaxies were emitting more infrared radiation than they should, and while 2 had natural explanations for this extra heat, the other 2 remain a mystery. Now, let's dive back into these 2 galaxies with the unexplained radiation. Michael Garrett thinks maybe the excess heat is just because of super thick dust clouds. But what if this dust is actually a sign of an advanced civilization? Hiding in plain sight, Brian Lackey from UC Berkeley is here to shake things up. He says that smart civilizations might be harnessing energy from their stars or even entire galaxies without making a big splash. And get this, they could be using smart dust, tiny, self-replicating nanobots that act like cosmic vacuum cleaners, sucking up energy from stars and space. So, this smart dust could give advanced civilizations a serious energy advantage. It's like having a network of super efficient power plants spread across space, instead of just one big megastructure. That way, they can fuel colonies on different planets and even use them as recharge stops when exploring the galaxy. But here's the thing, if we ever reach this level of tech, it'd be pretty hard to stay hidden from other civilizations. And if a hostile alien fleet was heading our way, our best bet would probably be to make a run for it. But don't worry, even though we're not at that stage yet, there are actually ways for humanity to keep under the radar of any observing Type 2 civilization. But wait, there's no escape from our solar system. We'd have to take it all with us. A Dyson sphere isn't the only megastructure in our future, though another game changer is the stellar engine. This bad boy would let us nudge our entire sun and its planets along a custom path through space. The question is, how on earth do you even move an entire star? You might be thinking, how do I even move a whole star? Well, buckle up, because there are actually some crazy ideas out there. First up, we have the Shkadov thruster, named after its brainy creator Leonid Shkadov. This stellar engine is as simple as it gets. Just imagine a ginormous mirror orbiting our sun, acting like an enormous light sail. The best part, it doesn't move around the sun at all. Instead, it hangs steady in space, ready to push our solar system off course. Now that we've got our mirror in place, let's talk about how it actually works its magic. As sunlight hits this massive mirror, it creates a weird kind of asymmetry. There's way more radiation on one side than the other. That imbalance gives us the thrust we need to get moving. But here's the thing, not only will our sun be off on a wild adventure, but all the planets and objects in our solar system will come along for the ride. So, with this crazy tech, would we be able to shake off our solar system's gravitational grip? Or are we stuck together like glue? Let's put some serious numbers behind our Shkadov thruster. If our mirror reflects half the sun's energy, we're talking about an insane force, 120, 8 times 10 to the 16th power newtons. Sounds like a real game changer, right? But here's the catch, it might just be too little too late. Even with that massive thrust, it would take our entire solar system over 1 million years to reach a speed of just 20 meters per second. And in all that time, we'd only cover an astonishingly tiny distance, about 300th of a light year. So, can you believe we've got a spacecraft idea that's actually slower than a snail? But wait, it gets even slower. If we stick with our mirror, we won't hit 20 kilometers per second until a billion years roll by. That's like forever. And get this, in all that time, we'd have only made it about 1/3 of the way through our home galaxy, the Milky Way, a whopping 34,000 light years. So, it looks like with this speed, escaping our cosmic neighborhood might be more of a fantasy than reality. But don't lose hope. There's another player in this game, and that's astronomer Matthew Kaplan from the University of Illinois, who dared to think outside the box, or mirror, rather by proposing we use solar plasma to give our sun a gentle nudge in a specific direction. Let's dive into Matthew Kaplan's radical idea, the Kaplan thruster. Imagine a massive jet engine right next to our sun, gobbling up about 1,000 kilograms of plasma every single second. As it moves towards the star, this powerhouse would spew out a plasma beam from one side and a blast of oxygen isotope from the other. The result, a gentle yet powerful push that propel our entire solar system forward. And here's the best part, the Kaplan thruster would leave Shkadov's sail in the dust. It could get our sun moving at an astonishing 200 kilometers per second in just 5 million years. That means, in just 1 million years, we'd be zooming past 30 light years of space, a speed and distance that would blow our current pace out of the water. Fasten your seatbelts, space fans. If we harness the power of the Kaplan thruster, we'll zoom past Proxima Centauri, our closest galactic neighbor, in a mere 130,000 years. Talk about interstellar road tripping. But wait, there's more. Alexander Svoronos from Yale University is taking it up a notch by merging Shkadov's sail with Kaplan's jet engine into the ultimate game changer, the Svoronos Star Tug. It's like a sci-fi space race, where we're pitting legendary engines against each other, and let me tell you, it's getting intense. Now, I wonder, what'll stop this cosmic competition? Maybe only something as mind-blowing as Dyson's tow truck. Let's dive into the heart of the Svoronos Star Tug, and what a beast it is. Svoronos suggests swapping Shkadov's sail with a solar-powered engine, transforming it into a cosmic tugboat that can literally pull our sun along. Mind-boggling, right? Theoretical calculations show this megastructure could accelerate our star to an astonishing 27% of the speed of light. That's approximately 80,000 kilometers per second. Just imagine the cosmic trailblazer we'd be if we made this work. But wait, things just got intense. The solar-powered engine required for the Svoronos Star Tug would guzzle so much fuel that our sun could potentially be turned into a brown dwarf. Talk about an astronomical price tag. While we'd still manage to outsmart Type Other civilizations with this setup, it's clear that the cost is steep. So, what's the next escape plan? Let's revisit that genius idea of smart dust, tiny particles packed with nanoelectronics that could connect and form a powerful network, acting as an alternative to massive Dyson spheres, or swarms. A clever solution to our cosmic conundrum. Now, let's bring out the big brains. SETI Institute's Seth Shostak and Royal astronomer Martin Rees are thinking